Hello, my name is Jemmy, and today I am going to be giving you a Python Go lesson on Matplotlib, which is a plotting library for the Python programming language. And I am going to be showing you this in Colab, but first I'm going to show you what Matplotlib can do. So it can show your like coordinates or output in lots of different ways, like the line plot, histogram, scatter plot, 3D plot. There's a lot more, and you can go check it out for yourself at this link, which is https at matplotlib.org, and then you can go and look at the different types of outputs they can give you. So the three that we're going to be doing is the one that's going to be like beeping in green right now. So yeah, this is the three that we're going to be doing: line plot, histogram, scatter plot, and that's it. So yeah, let's get right into Colab. So if we were to come look in Colab in here, I have my settings, as you can see, the dark thingy, and so I'm going to just explain the code one by one. Um, oh wait, we're also doing the column graph. This is an additional one that I don't think was in my slides. So yeah, I'm just going to show you what a column graph is once we get to there. And so let me just run our first code. This is to import matplotlib.pyplot as PLT. So it's just importing matplotlib right now. And there we go. Click Shift Enter. Well, first, I mean, if you don't have this yet, probably you don't, then you click on Connect over here and then save your file as a name that you can remember. So yeah, after that, then you can finally run this code, which is import matplotlib.pyplot as PLT. Then after that, we're going to be doing our first output. So this might be a bit confusing to you, like what's power level, what's damage, but think of it power level as x and damage as y. So power level is 1, comma 2, comma 3, comma 4, comma 5, and damage is 2, comma 5, comma 6, comma 7, comma 8. You can honestly just like write any number between 1 and 10 right now, and it wouldn't matter. You can actually write between 1 and 50, 1 and 100, anywhere you want, but the more numbers you have, the bigger the coordinate plane will be. And by the way, this is scatter. So let's just run this code. Okay, and here we are. So as you can see, it's a coordinate plane. If you don't know what a coordinate plane is, it has two values, x and y. So it will locate the dots at the value we set it to. So the damage right now is 2, and this is the damage, which is y. Damage is y. Power level is x. So damage is 2, power level is 1. So remember, we go to x first. So x is 1, then power level is 2, and it's right there. And then let's look at the next one. We go to x, and it's 2, so 2 is over here. And then we go up 5, and there we go. That's the dot. So as you can see, it's pretty simple. This is scatter, and you can add more numbers. The more numbers you add, the more bigger your coordinate plane will be. And basically, if you have an unequal value for both of them, then it's not going to work. So I mean, unequal value meaning like pretend your power level graph is like six of this. I'm not sure how to call it, but 6 values. But then your damage is only 5 values. Then it will come up an error. So you have to make your values inside your list match each other, so the same values. Well, okay, this is a bit confusing. The same values I mean by the amount of it. So this is like 5, this is 5 right now, it works. But if the amount turns into 6, and then in power level, and then in damage it only has an amount of 5, then it'll come up an error. Okay, so I'm pretty sure that makes sense. And yeah, that is scatter. So let me just show you something else. Plt.show here is really interesting because usually you would need this in like a Python editor, but in Google Colab they made it so that you don't need to have this code, but you can have it if you want. Pretend I uncommented that and then I shift enter. Okay, there we go. And as you can see, it works just like what we did earlier. And if you were to comment this, it would be the same thing. Uh, Okay, my bun bun is doing something. So yeah, that is uh PLT show. You can either have it or not have it, but just out of habit, make sure you have it. So at least you can have it and comment it or something. Just make sure it's there. And now let's move on to our second one. This is going to be graph of coordinate plane. This would I think it's called a graph. If I go back to my slides, it's a line plot. Sorry, it's a line plot. So this is a line plot. Okay, line plot. Okay, so what the line plot is, it's basically an adaptation of the coordinate plane. So instead of having dots like this, the line plot connects the dot together to make like a graph kind of ish looking thingy. And there we go. And the cool thing I really liked about graph, I remember, was that when it goes up and down. So I'm going to make just that. So let's go into our power level and damage. So let's see. Let's move this dot, which is the third one. So it's located at power level 3 and damage 6. So we're going to lower this to um 3 and power level 3 and damage 4. Okay, so damage 4, power level 3, and that's how. Let's run this. Okay, perfect. Now this is lower than this one, which means that the graph in here would probably go up and down. There we are. So it goes up, and then up. So yeah, that's really cool. I really like that for some reason. So I just made that right now. So yeah, that's line plot, which is an adaptation of our coordinate plane. And you can see here too that this is PLT show. It's there again. And one thing I noticed is that PLT show actually eliminates this crazy thingy, like it's a line of code. So if you don't want that, then you do PLT show, then that complicated line should disappear like this. And yeah, so that is line plot. Okay, let's move on to our histogram. A histogram is kind of like a coordinate plane, except it's like a column but connected to each other. So let's see the code first before we get into it. So we're first going to import random because this is going to have some random in it. And so yeah, once we imported random, we're going to set a variable. No, this is a list called damage, and then damage is going to have random dot ran range 0 to 100 for I in range 1000. So what this means, it might be a little complicated at first, but it means that it will random 1000 numbers, and each number will not random 1000 numbers. It will have 1000 numbers, and each 1000 numbers will be random between 0 to 100. So yeah, it'll have 1000 numbers with a value of 1 to 100. So yeah, that is it. Let me actually show you first to make it better to visualize. As you can see, I have a code that says print ages. Well, it's not ages anymore. It's damage, like so, and then click Shift Enter. And here should be a very long list of numbers ranging from 1 to 100. It's 1000, by the way. So yeah. Now let's uncover the rest. So I'm going to comment this print damage first, and now let's look at the rest. So here is plt.x label damage and plt.y label amount of Pokemon with that damage. So this, it might look complicated, but it's actually not. This is setting the name or setting the label of the x and y coordinates. So if you were to look back at our coordinate plane, that our scatter, then you can see that over here and over here, we usually call it by default x and y. But however, if we were to change it up, over here we could have a label, and then over here we could also have a label, and we could like set it to something else instead of x and y. Sorry, my bun. So yeah, that's these two lines of code. It will set the x and y label, and then this is the PLT histogram, ages color equal to C. Let me change this back to damage really quick. So yeah, what this is just it makes a histogram, and color is, this is really interesting. Color is setting the color of the graph. So as you can see, this one is blue. I guess, yeah, it's blue. But you can actually set the color of it, and there's red, green, blue, cyan, I'm pretty sure, and magenta. So yeah, those are the five colors you can set it to. I'm setting to cyan because I think it looks pretty cool. And without further ado, let's run this. And here we are. This is our histogram, and you can see that we have two labels here: amount of Pokemon with that damage and the damage itself. So at 100 damage, there is, if you were to follow the line, there would be approximately 100 Pokemons with 100 damage. So 40, I guess, ish, is about like 90, not 90, well, like, where is it, 85 around. And it's not as detailed because we have, our graph is pretty big. If you want detail, then you would have to go a bit on the smaller scale, um, or you could go research on how to make it small, more detailed. And yeah, so that is our histogram. Let me change the colors for you. So let's change it to red. Okay, like so. And here is a red histogram. As you can see, it randomed itself again, uh, because we set that in the code. So now we have a different histogram than before. If we did that one more time, it would be a different output, um, like so. So yeah, that is our histogram. And let's move on to our last output, which is the column graph. This is, the column graph might be a little confusing, but it's kind of like the histogram actually, except it's more detailed, or as I can say, detailed. And the thing that's different from the histogram is that instead of having numbers um as your how do you call it, as your value, it can have different stuff. So one of my values for the y coordinate is numbers, but on the x coordinates I changed it into Pokemons. So Magikarp, Metapod, Pikachu, Vaporeon, and Charizard. So I'll show you how it works. Shift enter. There we go. Here is my column graph, and so this is displaying like the damage and then the Pokemon. And as you can see, it's not, you can't tell what it was, right? However, we can just get our code from up here, X label and Y label, to set the X and Y for our code. So let's go into here. I'm pretty sure I'm just going to put it before they show, or yeah, I'll put it right here. And then I will, for the X, I'm going to say Pokemon, like so. And then for the, oh yeah, amount, no, damage. Okay, perfect. And then shift enter, and there we go. So the damage is over here, and then this is the Pokemon. So Magikarp has a damage, I set it as to 5, but however, since our graph is too big, we can't see it, but it's 5. And then Metapod is 25, which is half of 50, and Pikachu is 100, and Vaporeon is 250, and Charizard is the max, which is 400. And yeah, that is our Pokemon our Pythomon Go lesson on Matplotlib. There's much more to for you to see if you were to log in into this website, https://matplotlib.org. I'll show you right now. You can see different stuff, and then you can use this to adapt to your code. And yeah, you can play around with this a lot and have fun. So yeah, that's it for this lesson. I hope to see you in the next one. Bye.